connections, and I'm just going to talk about how this all works. And but I thought maybe what I would do before we just dive into the slides is I was actually pleased to see that Stephen actually sort of showed just how it's used at a higher level. You do it, you run the managed connections. I'll slow that one down a little bit, but just so you have an idea from a high level what we're talking about. Let's not do that. All right, what's going on? Still learning my new computer here, or my borrowed computer. But let's just bring up the studio and see what, first of all, like what the studio looks like, and when we're talking about managed connections, just what this is going to mean to you. And what it really means is before you do anything, before you work with your SQ tables, you're going to be creating a connection, which we've referred to as a managed connection. And this is a connection that you're going to be using to just provide all database access. And we've already created one here. We'll create a couple more, but I just thought you might want to look at the tool and see what it does, which is a connection looks something like this. And Steve ran through this very quickly. You create a connection ID that you will then be, all your tables that use that ID will be associated with it. You associate that with a server, a database server, and a database name. You make sure that it works. And then the rest of the studio, the rest of your application just knows how to use that connection. And so you have things like, I want to make a new table. What do I do? Well, you start by selecting a connection ID. Often it'll be the one you've created. And from that point on, that's all you need to know about. So I might create something called ID, make it an integer, make it the primary key. Let's make this let's go back up here. Should have done this first. And we'll make this identity true. I just created a table here. It's an empty table, we hope. There's the table that we just created. Using a managed ID, we've connected to an SQL database. That's kind of the goal of what we're looking for, is once you're in the managed IDs and you're working with SQL, from the DataFlex point of view, this is about as complicated as it gets. Now, there is still all the complications on the SQL side with the SQL server, with their management studio and all that, but we're not going to be talking about that today. But let's talk about how we got to that and then see what we can do with it. So, those of you that were in our Managed Connections class, this will be a little bit of a repeat, but I'll try to do it pretty quickly anyway, is let's make sure we understand SQL Connection Basics. When you connect to SQL, you're establishing a connection. And this is done by creating a connection string that contains the name of the database server, a default database, which is the database you'll be working with mostly within that server, any kind of login credentials, and then more things that when you connect to different kinds of SQL servers, they provide different kinds of special information. That's referred to as a connection string. You use that string to connect into the database, which is just often also referred to logging into the database. And once you're logged in, you just access your database tables. So, and then you work and you work and you work, and when you're finally done, you log out of the database. From an SQL point of view, there's really no such thing as opening a table. You log in to the database server, you have a default database, and you work with the tables inside of that. Uh, DataFlex. Uh, DataFlex was a more table-oriented system where you had a file list, and inside the file list it pointed to an individual table, and that table contained all the information about the table. It was sort of self-contained, and so you actually did open a table, which was a physical open of something. You would work with the table, and then when you were done, you would close the table. That's kind of the bottom-up approach, where instead of, you never really do a login, you just open a bunch of tables. And there are advantages and disadvantages of this. I'm sure everyone here could tell us the advantages, which is it created this very flexible way of portable, to create an application and then to be able to deploy it, to test it, to create multiple versions, to just by changing the pathing, the pathing of your files, or putting on a different computer with the same path, or moving it around. Because it was sort of file-based, it had all the flexibility of that. So when we needed to marry this with an SQL world, where it's you log into a server and you log on down, we started originally by making it a sort of a table-oriented basis. And so what would happen is rather than file list pointing to a table, it points to an intermediate file, the int file, which contains two kinds of information. It contains information about the connection string, and it contains information just about the table itself. The information about the table itself hardly ever changes. That's kind of a permanent thing that you would be able to take and never change and deploy wherever. The information about the server, of course, would change depending on where you were going to be installing the, where you're going to be installing your application. The information about the server in the int file was in this thing that looked like this, this int thing right here, where it says you've got server name equals server something, SQL Express. And the entire part, your application used this information, our tools use that information, but in order to, this was embedded in every int file, and so in order to change a connection, in order to move from this database to this database, you had to go in and you had to change all the int files, which was usually pretty safely said no fun. So we introduced something called connection IDs, and we did this years ago. And what connections ID, it was this abstract way of saying you have an ID that refers to your connection, and you put that ID in your int file, and then the connection is defined somewhere else. So what you can see happens here is that when you look at the like the sample part from the int file now, is instead of having this long server equals something, there's just the dfcon ID equals Chinook, that's your ID. So the connection, the actual mapping that this ID points to was defined somewhere else. And where was that somewhere else? Well, the somewhere else was either in a global driver INI file, or we said you can just write whatever, you can come up with your own solution. You can write a programming solution for it. There were problems with that. It was difficult to configure, it was difficult to maintain. The tools didn't directly support either of these methods. And then the framework didn't support it. So although you could make connection IDs work, developers had to do a fair amount of work to get it to all tie together. And to their credit, a lot of them did. They came up with very nice solutions. But we felt we could do better. We wanted something that was just easy and more flexible. So we introduced, and are introducing in 19.0, managed connections. And it works in a very similar way, which is a managed connection. It still uses the same connection IDs, but the information about where the connection information, the server string information is stored, is now fixed, and there's an interface to work with it. Basically, each connection information is stored on a workspace level, which is what was missing before. So you store all your stuff in a workspace. It's stored in a simple INI file, and it's normally stored in data dfcon id.ini. What this means is when you you can now take a workspace, move it from one place to another, and instead of having, if you then have to like point to a different server, all you have to do is you have to go in and change one configuration in one file, and you're done. So in the dfcon.ini file, you can see what it looks like. You've got this, there's going to be this section called connection, and it'll have the ID, it'll have the driver, it will have the login, it will have the server information. In this case, you can see where the server is, you can see where the database is, and then you see the credentials. And just to keep it simple, we'll make this trusted connections. Then in each int file, it'll just contain dfcon ID equals the ID, which points back to that. So you can all see how that works. Fairly simple. And the other thing, so you might have, like, you know, in a workspace, you might have 150 tables that all use the ID Chinook. If you then want to move it to a different database, how many files do you have to change to do that? The answer is 1. I hope we accept it, because you're not going to change you're not going to be changing the int files. You're just going to be changing this one file, and that's kind of the basis of managed connections. And you might think of managed connections as being connection IDs 2.0. So how is all this done? Well, this is all done by we've created a new class, which is called a C connection class. It's a global class. It's created once. You put it in your application, and all of the managed connections is run through that class. It works with any of our CLI drivers, 6.2 or above, and as the slide said, it's a global object that lets you create, maintain connection IDs, use connection IDs in your int files, define connection IDs in a workspace, and then also handle login and logout, which was another issue I'll get to in another slides, which is when you're logging in and logging out and you're using credentials, how do you make that secure, and how do you make that work? And then finally, this also becomes the basis for using embedded SQL. That it's a simpler model. And to understand the model, again, think of it as, maybe I'll get to I'll explain it now. The traditional DataFlex style of an application is you run your application, and then when it comes to the first open statement, it then says, oh, I'll open the table, but if it's using connectivity, it says, oh, I need to find this table's database server, and then I need to log into the server. Once you've logged into the server, then it proceeds. It opens the next table. It goes through that same exercise and says, oh, here's the database server. I need to log into it. Oh, I'm already logged into it. I don't need to do it. I'll just keep going. And so what happens is we hid the login process so that you open the table and it just seemed to magically log in. While that seemed like a good idea, what it did is it created environments that in an SQL application kind of basis world didn't really fit the model, because in fact, this is what Martin would always say is, like, in SQL, what you do is you connect to the database, and that's the first thing you do. And as soon as you connect to the database, then you do other things. If you can't connect to the database, you don't do anything else. So it's like you don't run the application up to a certain point and then just see if you can log in. So he's actually correct. And so what managed connections lets you do in an application is it becomes much more, you start your application, you'll register your managed connections, then you'll log into your database, or you'll log into your databases. If it fails, do you want to run the rest of your application? And the answer to that is usually no. In a deployment basis, if you can't log into your database, you don't want to then try to continue to run other things unless you have special ways to recover it. So anyway, this C connection class is what's going to make all of that possible. The other part of managed connections are the tools. All of our tools in DataFlex, which means the Studio, the other Database Explorer, the other tools, our wizards, all make it easy to manage, create, look at, and use managed connections. It just, it's built in the system now. It's easy to create tables using managed connections. I just did it. That some of the things that I was showing you, like look at this int file and look at this file and look at that, I'm explaining that just so you can see what the innards look like, and even that's pretty simple. But for the most part, you're not even going to have to deal with these. The tools are just going to be doing it for you. What does it take to use managed applications in a DataFlex code? You need to add a couple lines of code. And as you can see, these are the, in a typical DataFlex application, you have an application object. You just need to drop this object inside there, configure it using the Studio, configure it using the tools, and the rest of your application works. And in fact, from this point on, any new applications that you create, any new workspaces you create, the Studio will automatically put this code in for you. If you have an existing application that you need to start using managed connections, all you have to do is just drop that code in there, and you've got a good start. Okay, one of the things that managed connection lets you do, is I kept referring to, is that when you connect, you connect to a database, and then you use all the tables in that database. So what that kind of implies is that in an application, you need one connection. So you have a connection, let's say we call it ID, and you've got 50, you've got a database and you've got 50 tables. All those things will use one ID. For the most part, that's all you need, but managed connections also supports this concept called multiple connections and alternate connections. And what is a multiple connection? A multiple connection is when you need to talk to tables from different database servers. I mean, normally you don't do that. Normally you have a main database server you work through, but it's probably it's not completely atypical to have an application that then needs to go out to some other database server to access something. And so how do you do that? You just create a second managed connection ID with a second connection, and then you just, when you work with those tables, you set those up with that ID. And that's what we refer to as a multiple server. Those of you who are using, I mean, I'm assuming this is something that we all encounter, where we have a main database, then we have to go out to other databases to connect to it. So it's very easy to do. And the important thing here is each server will have its own unique ID. So you might have ID remote. You might call it like remote connection or whatever. And then now, instead of when you configure your system, instead of having to configure one ID, you have to configure two IDs. And the tables that are defined for either one ID or the other, and it just works. The other one is alternate connections, which was not something we had originally planned on putting in there. You could do it, but we were going to make you work harder for it, but we got talked out of it, is frequently during development especially, you may have a single connection, but you want to be using this database. Now, very easily and very quickly, you want to test a different database. You want to test a different database, or you might want to test it on a different server, or you may want to take all your data, duplicate it, move it somewhere else, and then use that server and then go back and use the other server. The original idea was, well, if you want to do that, just go into your managed connection manager and just change the connection. Then when you want to go to the other one, change the connection. Well, it's something that you do often enough now that what you can do is you can actually have, for managed connections, the same ID can have multiple definitions. But only one of those definitions can be enabled at any one time. So you may have like 3 databases that are all identical that you like to work with. And so within the managed connection, you can set it up and say, I want to use this connection. It's enabled. The other 2 are disabled. But then you can change it so that another one gets enabled. And it just makes it like, it makes development very, very easy. And it's something that we'll show you how to do that in a second. So the difference here is that where multiple connections, you'll have multiple IDs, unique IDs. With alternate connections, it's the same ID, but only one will ever be active. OK, just to sort of like make this a little more concrete, you can see what a connection with multiple connections would look like, what the actual INI file would look like. And you can see I have something called ID1. That's one connection. And it's pointing to a SQL database equals order. Then connection 2 is pointing to something. Connection 2's ID is RS1, and that points to something else. So this, you can just see how this starts to build up. Alternate connections. It's the same idea, except it's the same ID in both of these. But if you look at the bottom, one is disabled and the other is enabled. And if the studio maintains all this for you and the tools maintain all this for you, and so this is how you work with alternate connections. We'll look at that in a second. The other part of managed connections that the other problem that we wanted to solve for you was the whole thing about database login, encryptions, and how to handle that. And what you need to understand is when an application needs to log into a database server, well, an application does need to log into a database server. It normally happens when the application is started. It's required. If it's not going to work, if the login fails, the application just should not be run because you have no access to data. And normally you want it to be quiet. This is not the login that an end user should see. End users do not log into databases. End users log into applications. And we want to use, and because it's silent, we want to use the credential information, credentials being user ID and a password, or possibly a trusted connection, or a DSN. You want to use the credentialed information that's stored somewhere. In this case, it's going to be stored in our connections INI file. And if it's going to be stored somewhere, that credential information should be secure. You don't want people to look at the passwords and know what they are, so you need some kind of encryption. Managed Connections handles all of this. The one thing I do want to stress, just so there's no confusion, is that an application login and a database login are not the same thing. You probably don't want them to be the same thing. When you run your application and it comes up with a little login screen and you log in, you're logging into your application, or your user is logging into your application. You probably have your own system that defines rights about you're allowed to use this menu, you're allowed to use this, you're allowed to change that. That's the stuff that you build. Generally, your roles and rights system that you have in your application is something that you've built, that you've stored in a database. That database, that database is the thing that you need to log into before. So the database login is generally what's needed to access your application. So you can open your database and then do an application login. They're two separate things, and if you try to do it in one step, it's not going to work out. So storing credentials. An encrypted password created some challenges that we figured, okay, this will be no problem. All we will do is when you have passwords and we store the password in the connections INI file, we'll come up with an encryption system. That was easy enough to do. We did it. But then it turned out that our tools need to use that same, our tools need to be able to use that same encrypted password. And that creates a security issue, which is if we're going to use the same encrypted password, it means we know what strategy you're using to encrypt, to provide access to your database. So and from a security point of view, you don't want that. You don't want us to know how to take one of your DataFlex applications and decrypt your password. So, and then at the same time, our tools need to know how to do this. So it was kind of this problem of what to do, and what we realized is that in order to solve this, we need to store 2 password encryptions. We need to store one for your application, and we need to store one for our tools. For your application, while we provide a template for how the encryption should work, we don't know what method you're using. We don't know how you encrypt your database. And not only that, you can, even if we have an idea, you can customize it. So we have no idea how the database encryption works for your application. Similarly, we will be storing, when you're doing development, our own password, which we call DFPWD, which uses our own encryption method that our tools know how to use. So you don't know how our encryption tool works, but our encryption tool just does it. We don't know how your encryption tool works, but your encryption tool just does it. And what this does is it allows for everything to just work. That probably sounded more complicated than it needs to be. It'll look better when I explain it. But and the other thing is, when we're talking about you have an encryption method, we have an encryption method, you're thinking, oh, you mean I have to create my own encryption method? No. No, we provide a class, we provide an encryption class, and we even provide a way so that every single workspace that you're running has its own unique encryption seed, so that even without writing a line of code, every workspace that you create will have a unique encryption mechanism that we won't know, and that the person next to you won't know. It won't be transferable. How does all this work? It actually means the encryption is built into your application. The logic to do the encryption is built into your application. And we provide the class. The C connection class does that. It uses a helper class that can be modified. And then we have our tools. We do a similar thing, but we've modified the encryption logic enough so that internally we know how it works, you don't, and vice versa. So what this means is you'll see a connection IN file with passwords where you'll see something like app, the user ID is app user, and then you'll see an encrypted password, pretend that's encrypted, and then you'll see a password for your application and a password for the tools. You actually won't even see these because you won't be bringing these files up all that much. So how do you do a login? If this is something that's only supposed to happen once to get your application installed, some kind of tool is required to configure your credentials. And that tool is just a standard login, which actually when Steve was running his thing, you saw that little box appear. And the idea behind the database login is it's only invoked when needed, which means it only invoked when it tries to do a login to the database server, it fails, and then it brings it up. You type in the information. If you succeed, it saves the information, encrypts it, it writes it out to the file, and it just, you're ready to go. So basically, we have a tool that is invoked when needed. It lets you type it in. It stores the credentials. It applies the encryption rules that are set in your application. We provide that tool. And as I mentioned, the workspace uses a random key to seed it's actually a random string to seed the encryption. And then the question was, okay, so where should that tool be? And we decided the best place to put that tool is to actually embed it directly in a Windows application. Because it's code-based and because it's workspace-based, there are going to be times when you need to run this tool, The best time to run the tool is when you're when you're running your application and you can't log into the database. So we embed the tool in your application. You can also just create a standalone version of it, and you would actually need a standalone version of it for the web applications, because while you could create a web version of it, it seemed funny to be configuring your database login configurations on a web at the end user on your web application. And then our applications in the studio use a similar technique. This is the part of the connection string that uses something called object packages. And this is the login encryption and the database login dialog.dg. This handles the custom encryption. This handles the login. We provide these two packages. If you want to customize it and do something different, you want to make your login look different, if you want to change your encryption a little bit, what we encourage you to do is take those files, make copies of them, put them in a library you've got, or put them in your workspace, and modify it. And then when you modify it, you would use the new name that you're using there, and you're ready to go. Okay, one other thing I wanted to mention that's possible with this is something called dynamic connections. And what are dynamic connections? Is one of the other goals of C Connection was to make it very easy or make it easier to change a connection, not just during development, but also when you're running an application. So that when you're writing your application, to have as an advanced feature the capability of basically changing databases on the fly. And there's levels of that. You might be able, when your application starts up, you may want to change the connection. You may want to select a different, you're not changing connection, but just select a different connection depending on how you started. And there's various ways to do it. You can do it on a code base. There's even like a command line prompt you can pass that says, no, instead of using this connection INI file, use this one. So that when you start up an application, you could easily you could have you could be running them for different sites, and then just depending on how they start up, you're looking at completely different databases. I mean, this is really easy to do. There's even a feature that lets you, while the application is running, you're up and running, to do something to just change the database within the server on the fly. So it's the default database. So you're working on one database. This assumes that you have a database server, lots of databases that are all identical or close enough. And then just by doing something, instead of looking at this database, you just switch over to that database. And the nice thing about this is this, you don't have to reopen files, you don't have to do anything. There is actually just about no overhead involved with this, so it can be done very, very quickly. To push this just a little bit further, we also added something that lets you redirect connections of not just the database within a single database server, but you could actually be pointing, while you're running, you can be looking at a database server and then redirect it to a database server somewhere else, completely different, without having to close your tables, without having to do anything. And again, the only real thing you need to make sure that you do is that the tables are similar enough so that the same, your same programming logic works on this. And this is really powerful because this also can be done without internally logging out and logging into connections. So again, it's very, very fast. And what's that going to be useful for? It's going to pave the way for multi-tenant, well, all of this paves the way for multi-tenant applications. And the redirect is going to be particularly useful for web applications, where now you have a single instance of a web application, and you might have multiple users using the web application. Each time a different user from a completely different company connects to that same web application, the first thing the web application can do is redirect to one server, then redirect to a different server, redirect to a different server. And by keeping all those connections alive at the same time, that can be really, really fast. We're still, as I said, this paves the way for it. This is you're going to see coming in the next versions, but this is going to be like a really nice system. Finally, just compatibility. You need 6.2 and above. The changes have been implemented to be 100% backwards compatible. That you add those packages I told you about to an existing application, but you don't define managed connections, your application will work exactly the way it always did. So you don't use embedded database doesn't support SQL managed connections, but if you put the code in there, it doesn't hurt it either. Existing SQL database applications will work just fine. Pervasive applications will work fine. They just won't use managed connections. No changes are required to keep doing what you're doing. For existing application, you just need to add the code and configure your managed connections, and you're ready to go. So let's go back to this guy now, and just after all that babbling, just see if any of this actually makes sense. Let's start by this. When you go to the database manager now, you'll see that there's a connection manager that lets you do all the things. And now, hopefully, without looking at files and all that kind of stuff, what you're going to say is we have a managed connection. And what if I wanted to create an alternate connection? Well, all you do is, let's start with a multiple connection. So I have an application. This is my order application. I want to hook up to yet a different database. So I'm going to create an ID called something else. I could call it whatever I want. But I'll call it Chinook. It'll be the same server, but I'm going to connect to a completely different database. Test it. We have now created the capability. We now have two connections. We now have the capability of connecting simultaneously to two different servers. That's all it takes. Well, what does that mean? It means I should save it. Means I could do something like this. I could do database connect. The wizards understand managed connections. It'll say which connection do I want to connect to? Connecting to Chinook. Connect to new. And I will just bring in one table. I didn't explain the wizard because I think we've all seen it before, and I assume that we all do the same thing with wizards is we don't read what's there anyway. Anyway, what you'll see now is we've now added a table to our workspace in our application that comes from a completely different source. If you open up the connections, you can see this is Chinook. The ID is Chinook. If I go back to customer, look at the connections, you can see that this is order one, and the ID is order one, and it's pointing to something completely different. So that's all that's involved to be able to have an application that connects to multiple databases. And maybe I should have started here and not done all the babbling, because this is, but because I can't help but babble. This is the file that we don't have to worry about, but this is the one that the tool is just maintaining. And just also to prove that the album is there, you can see it in the table viewer. Okay, so we've seen how to do a multiple collection. What's this alternate connection thing? Well, what I could do is say, when I'm testing this, I want to test this with trusted, but I also want to test it with actual credentials. So what I'm going to do is add an alternate for order. So I give it the same name. Since I already have one, I'm not going to do this. And use the same database. But I'm going to log into it a different way. That looks successful. And so now I have two alternate connections that I can make either one of these active. Watch what happens now when we'll start by keeping this one active. Let's make sure that this actually works. We're good, but we'll keep it active. We'll save it. So I'm just using the regular connection, running the application, and it works just fine. Now I go in and I say, let's use the alternate connection, which requires actual login. So I'm going to enable that. Notice it disables the other one. Only one can be active at a time. When I run this now, it doesn't know how to log into this. The application will not know how to log into the database. So I need to run this database login tool to do it. Or I can just not worry about it because I know it's embedded in the application. And it will ask me to type in a password. And I can remember it. And I'm in there. Now, if I run the application again, are we going to see that login dialog? The answer should be no, because it's not needed. If you look at the connection INI file, which, again, we haven't had to work about, you can see now it's got these funny encrypted passwords down there. That's what the tool did. That's how it worked. To see if we're really following, and this is something you wouldn't normally have to do, but if I removed the user password, so it's gone, we lost it, this, what do you expect is going to happen when I run the application again? It'll ask again. So this would be something that when you install your application, when you deploy your application, this is generally something that you will only do one time. You have to spell right, apparently. And from this point on, then everybody who's logging into your application will now have access to this application. So ignoring, not even worrying about this stuff, what you'll see is how managed connections makes it easy to add tables. It makes it easy to create multiple tables, alter tables, do all these things just from the studio, just with the tools. And so just to summarize, managed connections are a much better fit for the SQL client-server databases. It makes your applications behave more sensibly because you're forced, when your application runs, it now runs sort of in a top-down style. During development, it's easy to work with multiple copies of databases. It makes it easy to deploy database servers because you can just take a server, install everything, and only have to configure one file. It makes it easier to exchange SQL data. You just script the data. You send the workspace. You can have a single config file with multiple servers, alternate servers. Encryption is handled for you automatically. It's worked with embedded SQL. And this is just barely the beginning. It's quite extendable. It's a DataFlex class. Therefore, it can completely build and completely extend it. And that's managed connections. Thanks.